Okay, guys, so as we know, we have to go through this process of interruption. So we're continuing from the on the exercise. So we're at question 6. And so question 6, Ms. Tavia, are you hearing me now?
Yes, sir.
Oh, sorry about that. I said question 6. I think I'm at question 5. I was asking you in the previous segment to give me a definition for prime number. Were you hearing me then? Ms. Tavia? Are you hearing me, Ms. Tavia? Can you respond, please? All right, so I'm really not sure what is happening. All right, so we're at question 5. And question 5 says that you're to name each of the following. Name each of the following sets. Now, so from question 1 to, oh, sorry, I keep going to question 6. I don't know why I'm jumping the gun. All right, some persons are being affected by the rain, and so as a result, their internet connection is not stable. All right, so question 5 here, it says Q equals to multiples of 3 up to 33. So I'm going to ask, Miss Cold Spring. Are you there? Miss Cold Spring, are you hearing us?
Yes, I'm here.
Okay, do you want to attempt question 5 for us? Just tell list the numbers of the multiple of 3 up to 33.
3, 6, 9, 12, 15, 18, 21, 24, 27, 30.
Up to 33. All right.
30.
All right. Thanks much, Miss Goldsmith. All right. So the next part now is question 6, and here we are to name each of the following sets. Now, naming the sets here is not really naming them in terms of the capital letters that we had mentioned before, but they want you to name them in terms of description. So for question 6, how would you describe question 6? Ms. Shea, describe question 6 for us.
Sorry about that, sir. So I will describe question 6 as multiples of.
Don't forget the curly brackets, Miss. The set of, and then you give the description.
So I will describe this set as set of multiples of 50.
Set of multiples of 50. That's what you said, Miss Shay?
Yes, sir.
All right. All right. We're going to hold a little bit onto your answer, Miss Shay. I'm going to ask somebody else to give me their answer. Ms. Clark, I see where your hand is up. So you want to give us your answer to question 6?
Yes, sir. The set of multiple of 5 up to 25 inclusive.
Yes. So Ms. Shea, do you see
Yes, sir.
Clark's description is different from yours and why?
Yes, sir.
All right, what is it that is different in Ms. Clark's description?
She basically used the lowest common factor multiple, which would be 5, and she also said that um it is 5 inclusive going up, something like that.
Right.
I
So
did
I want
inclusive.
you to have it clear in your mind, Ms. Shea. I don't want to hear something like that. I want you to know exactly what we are talking about. So do you have a clear idea the difference between factors and multiples?
Yes, sir.
All right. So what are factors?
Sir, factors are numbers that can go into bigger numbers without leaving a remainder.
Very good. So now what are multiples?
So multiples are numbers that factors can be divided into without leaving a remainder.
Correct. So if we say multiples of 5, what does that mean?
So if we say multiples of 5, it means that um it is numbers that 5 can go into.
Exactly. So all the multiples of 5 would be numbers that 5 can go into without a remainder. So it is simple to find them. We just simply count by 5 because all the numbers that you get by counting by 5, 5 can go into them. All right, is that clear?
Yes, sir.
All right, moving along now. So, Miss Amanda, are you hearing me? Miss Amanda? Miss Scott, are you hearing me? Scott always missing in action. Miss Amanda, something is wrong with your mic. I need you to interact with us. I don't want to see you chatting. Can you speak on your mic, please? Amanda? Guys, the more you participate is the better you'll understand. All right. Miss Amanda says she's on the road, not the place that you should be while you're in a class. But I guess everybody have circumstances. All right. Miss Taylor, it's Moisha. Can you pronounce your name correctly for me, please?
Moija.
Moisha. Sorry about that. Miss Moisha, can you describe question 7, the set B for me, please?
Set of family members.
All right. Would that be sufficient enough in specifying this set?
Yeah, it's the set that is describing persons in a family.
All right.
Not all the persons.
All right. So I will take that answer to be if you're Because your family, if you're referring to your immediate family, would be the nuclear family. All right, so I'll take your description.
Or sets of relatives.
Okay. All right, now let me find someone now who can describe this set for me. Mr. Adriano, can you describe set C for me, question 8? Mr. Adriano, are you hearing me? Not getting any response from Mr. Adriano at all. Mr. Authors, are you hearing me? Can you describe C for me? Question 8.
I'm unable to see it, sir.
I didn't hear that, Mr. Authors.
I'm unable to see it.
Oh, you're unable to see it. Maybe you could try to change your screen profile on the Zoom, and maybe it will take into because sometimes what happens, depending on your screen profile, some of the things on the screen will drop off your screen. So you can change the profile. All right, so in the meantime, let me ask somebody else. Ms. Trivia, can you describe C for me?
Yes, sir.
All right, so go ahead.
C is a set of prime numbers from 3 to 17 inclusive.
Very good, Ms. Trivia. Thanks much. All right, moving along. And we're going to look now at types of sets. All right, so we classify sets in 4 basic types. So the first one we talk about finite sets, or some people may pronounce it as finite sets. Then we talk about infinite sets, the empty set, or sometimes referred to as the null set. And then we have equal sets. All right, now starting with a finite set. So a set in which all the elements can be listed and counted is called a finite set. So you should be able to list all the members, or you should be able to count all the members. So those are what we refer to as finite set. Now, with a finite set, it means that it is countable. You come to a definite end with the members. So that's what we mean by finite. Now, example, we have these 2 members in this set. This is a finite set because we can list them and we can count them. Now, infinite set, a set in which it is impossible to list all of the elements and impossible to count, is called a infinite set. So an infinite set is one in which it is impossible to list or to count all the elements or all the members. And so in this case, any set that we are unable to list or count all the members, then we will consider it to be infinite. So if we're thinking about the stars in the heaven, then you may have a real challenge to count them. So it is somewhat impossible to count all the stars in the heaven, and even to list them, if you're going to list them in terms of, if you're naming them and listing them. So in that case, that would be an infinite set. So here we have the set 1, 2, 3. Now for an infinite set, we generally show that the set continues by putting a string of dots after the members. So here we start off 1, 2, 3, ... meaning that it goes on and on without ending. And that's why we call it an infinite set, because the word infinite tells you that you're going on without ending. All right. Now moving on. So we have the empty or null set. And we would have mentioned this set already, that it consists of no members whatsoever. So it is a set without members. These are the symbols that are commonly used when we are referring to empty set. So you may see the braces without any elements between them. That is also used to denote as an empty set. Remember, I would have mentioned 5 before, and that is also one symbol used for empty set. And sometimes they might combine the two symbols to mean empty set. So you put the 5 between the braces, and that also means empty set. All right. Now, here we have a statement saying that if the number of elements in A is 0, then A is empty, which is use the symbol 5. Now, this is what we call an if-then statement. So you have an if section to the statement, and you have a then section to the statement. So the if part of a statement is what we call the condition. So if this condition exists, then the then part we call the conclusion. So the if is a condition and the then is a conclusion. So what is a condition? If the number of elements in A equals 0, if that condition exists, then we can conclude that A is equal to the empty set. All right, so I'm drawing your attention to these statements because you will see a lot of if-then statements in maths, and you should understand that the if part is known as the conditional part, meaning that that condition has to exist before the conclusion can be true. All right, so bear that in mind. All right, moving along. So here we have the definition for equal sets. So equal sets have the same members, but not necessarily in the same order. So once two sets have the same members, then they're equal. Take for instance, if you have a classroom and the same students attend the class every day, but even though some days some students may change their seating position, it still does not make the set different. It's the same class. That means if the members are rearranged in a set, but they are the same exact elements, then the sets are equal. So here we have the set A, which is the order of the letters are A, B, C, D. And then we have the set B with the orders D, B, C, A. Now we can conclude that the set A is equal to the set B because their members are the same. So since A and B have the same members, and most importantly, they have the same amount of members, right? Because two sets can have the same members, but one can have an additional member And in that case, they would not be equal. So for two sets to be really equal, the number of elements in both sets have to be the same and the members have to be the same. So here, the number of elements in A would be 4. You just simply count the members. So we have 1, 2, 3, 4 members in A. And the number of elements in B would be 4 as well. We have 1, 2, 3, 4 elements in B. And we see where all the members in A are the same members in B. They're only arranged differently. So therefore, A is equal to B. So if two sets, C and D, are not equal, we will write that slash down the equal sign there to mean not equal. All right. So remember, I had mentioned before that whenever you have an operation or a symbol, putting a slash through it just simply means you're saying not. All right. Moving along. Now, equivalent set. Now, this was not really classified in the list of 4 types of set, but you can think of it pretty much in a similar sense, falling under the equal set. Now, sets are equivalent. So the definition here, 2 sets are said to be equivalent if there is a one-to-one correspondence between the elements of the 2 sets. Now, notice we say there's a one-to-one correspondent. Anybody can tell me what you think that means, Ms. Cox? When we say we have one-to-one correspondence between 2 sets, what it means?
Sir, don't sure. Sir, I must come from somewhere. I pick up, sir.
You know, I didn't hear it so clearly a while ago. You want to say it again?
Are you hearing me?
I'm hearing you loud and clear now.
I was saying that I'm not sure because me just come and me miss almost like class, sir.
Yeah, I know, but this doesn't have anything to do with what we have discussed before. This is just this.
So, sir, if you read it and explain it to you?
No, so the question is just what is one-to-one corresponding? Still not sure. All right, let me ask somebody else to give it to try. Ms. Waysam, one-to-one correspondent. What do you make of that?
One member in each, sir.
All right, so it said that 2 sets are said to be equivalent if there is a one-to-one correspondence between the elements of the 2 sets.
So it could be that one or both sets are sharing the same common members.
No, it wouldn't be any common members. So you can think of it in terms of probably a volleyball team, a netball team, or a football team. So you have two teams, 2 sets. The one-to-one correspondent means that they have the same amount of members, even though their members are different. So you can match one from one team with one on the other team. Is that clear, guys?
Yes, sir.
Okay, so one-to-one correspondence mean sets that have the same number of elements and you can match one member to the other. They don't necessarily mean that they have the same members. All right, so equivalent sets have the same number of elements, but the members are not necessarily the same. So the set A, B, C, D, and the set 1, 2, 3, 4, if you count the number of members, you will see that you have 4 members in each of them, but the members are different. So what makes them equivalent is the fact that you can match one to the other. All right, so you can match A to 1, B to 2, C to 3, and D to 4. So equivalent sets only need to have the same number of elements. The members are not necessarily going to be the same. Is that clear, guys? Let me see your hands. All right. So I'm just seeing just a few persons, but I hope that for the majority, that few persons speak for the majority. All right, moving along. Now, students, if you're there listening to me and you're not sure what is happening in terms of what I'm explaining, you have a responsibility to ask questions, students. Don't just listen to me moving along without you asking questions for clarification, because you may not get the opportunity again to ask a question once it is gone. All right, you might not even remember what question you wanted to find out, but right then and there, once the question is in your mind, ask it so that you can remove doubts. And sometimes I know people hesitate to ask questions because they don't want to feel like anybody else is judging them, or they feel like somebody else might look at their question as being silly or stupid. Hello, this is a learning environment, and there's no silly question in this environment. If you have a question, it means that you have doubts. And if you have doubts, it means that you won't be able to understand us until you get clarification. So you need to ask questions so that you clarify any doubts that you have, so that you don't carry those doubts to exam with you. All right, moving on. So the word to the wise is sufficient. Here we are on our second exercise, and we are also going to be going through this exercise orally. So I don't know if you want people to, let me just call on you individually just the same, and I'll just try to find somebody who I have not called on yet to try. Mr. Ageno, are you hearing me now?
Yes, sir.
Okay. Now, exercise 2, say which of the following sets are finite, infinite, or null. So we're just going to state whether the set is finite, whether it is infinite, or whether it is null. Mr. Giovanni, question 1, finite, infinite, or null?
Infinite, sir.
Why?
Because the list continues, that's why.
How you know that the list continues?
As long as the dot that is behind an element to show that the list.
All right, sufficient. All right, Ageno, question 2, finite, infinite, or not?
Finite, sir.
Why is it finite?
Because there's no dot at the end.
Right. What by definition, what a finite set is?
Finite set are sets that you can count.
So you can list members.
Yes, you can count and list them.
All right. Now the set of points on the circumference of a circle. Let me find somebody.
Right, can I answer?
Hold on.
Oh, sorry.
Miss Cold Spring. Gold, is it cold or gold? Miss Cold Spring, is that correct? I mean, am I calling your name correctly? Miss Cold Spring? Are you hearing me, Miss Brittany? All right, I'm not sure if she's hearing me. All right. Miss Moija, are you there? Miss Moija? I get the sense that people are shying away from this question. All right, Miss Shay, are you hearing me?
Yes, sir.
All right, question 3, finite, infinite or not?
Sir, it is finite.
Anybody else agree with Miss Shay? Let me see the hand of those who are in agreement with Miss Shay. All right, so Mr. Paisley, why do you say it is finite? Huh?
Sir, I guess.
Oh, you're guessing. All right, Miss Trivia, are you hearing me?
Yes, sir.
What is your answer to this one? The set of
I would say null, sir.
null. All right. I'm not saying yeah or nay yet, Miss Trivia. I saw where Miss Miss Cold Spring would have just re-entered the class. Miss Cold Spring, are you hearing me now?
I'm hearing, the Wi-Fi.
I realize. Now the question is question 3. You have to state whether or not the set is finite, infinite, or null. So the set of points on the circumference of a circle, finite, infinite, or null, which of them?
Infinite.
All right, why you say infinite?
Because the number of points on a circumference cannot be pointed out.
Okay. Can you give me a little bit more detail? Miss Cold Spring. Hopefully I'm calling or pronouncing your name correctly. Are you there, Miss? I guess Miss Cold Spring don't have any more detail to share with us. Anybody else would like to try and give me their reason? Mr. Campbell, are you there?
Yes, sir.
All right, you want to try to give me your answer and the reason to your answer, please.
Number 5.
No, the same one, question 3.
Question what, sir? 3?
Yeah, the set of points on the circumference of a circle. Is it finite, infinite, or null? And why?
I'd say infinite.
Okay, why?
Because circumference is like on a circle, no, sir?
Yeah, that distance around the circle is what we call the circumference, or we sometimes call it the perimeter of a circle. So why is it that it is infinite?
Because an infinite amount of well, you can get an infinite amount of points out of it. So.
There is a what?
You can get an infinite amount of points out of it.
Okay. All right. I I will accept that. So lines are made up of points, but it is impossible to make a distinction on a line between points. So because each point can be broke up into smaller and smaller and smaller points, and that can go on infinitely many times. So to try to break one point into two and then break another point into two, it will go on forever. All right, so it's actually infinite. And so based on that, that's the reason for it. The set of letters in the alphabet, Miss Shea, finite, infinite, or no?
Finite.
All right. I think everybody can agree with you on that. Miss Clark, the set of even numbers which can be divided exactly by 3.
No, sir, because I cannot divide an even number by odd number without being
Are you sure? Can 30 be divided by 3?
Yes, sir.
Can 60 be divided by 3?
Yes, sir.
Right, so aren't those even numbers? So the question now, is it finite, infinite, or null? So we can rule out null.
Infinite, sir.
Infinite, all right, very good. Infinite. So we're at question 6. And so let me find somebody else. Miss Cox, are you there? Miss Cox?
Yes, sir.
Yes, question 6 is yours. A set of odd numbers which can be divided exactly by 2.
Sir, finite.
Odd numbers that can be divided exactly by 2.
Sorry, you hear me say?
Yeah, man, I'm hearing you, but I wanted to think about your answer. I'm not in agreement with your answer.
All right, sir. Me say infinite because the odd numbers them just sir then I stop at 100 because it can continue. So me say finite.
All right, you see what the question is asking? The set of odd numbers which can be divided or can be exactly divided by 2. Now, the question that you should ask yourself, Ms. Cox, is what is an odd number? Ms. Cox?
Yes, sir.
Yeah, are you able to give me a definition for an odd number?
Sir, so basically odd numbers are numbers that I don't even know if it's this, sir.
All right, so you're not sure.